All right, guys, in this video, we're going to look at residuals, and we're also going to look at what is the least square regression line, or what's the line of best fit. We're going to call it an LSRL, least square regression line, from here on out, just because that's the math technical AP term. So we're going to talk about that. This video is going to be pretty short. I'm only going to go over a couple things, and then we're going to do, I'll talk about this in class, but we're going to go into an activity at some point that hopefully we can do remotely, so we'll try that. But yeah, we'll go from there. So what is a residual? That's kind of where we left off from last time. Last time we talked about a couple different things. What does the slope and y-intercept of the line mean? How to make scatter plots, and talking about how to describe them. So in this video, like I said, we're going to talk about residuals and what they are. So a residual, so how do you calculate a residual first? Is equal to the observed value of y minus the predicted value of y. So what this is, a residual is basically a measure of error. Okay, so you're looking at the difference between what was in the actual data set and how well your line did at predicting that. Okay, so when we write this out, we write, you have your residual. So we have residual is equal to, and then in your textbook, and when you look at it, like different formulas, you're gonna have y minus y hat. Okay, where y hat represents your predicted value. Okay, so whenever you see this hat symbol, you look at the predicted value. Okay, so this and this correspond to each other. And like I said, this is a measure of error. So how far away did your line, how far is your line away from the actual data value in the set? Okay. So, and I'm going to show something kind of interesting about this whole thing in class. So we'll kind of do that. Let's see. And then in words, this is the, oops, the difference between an observed value of the response variable and the value predicted by our regression line. And so that's kind of what we're looking at here. That's what a residual is. Okay, so next question here is find the residual, calculate and interpret the residual for the can that was tapped for 4 seconds and has 265 milliliters left. Okay, so this right here, the 265 is your actual y value. Okay, so this is what was actually found in the data set, right? So we tapped it for 4 seconds in the actual data set, and we had 265 milliliters left. Okay, so now if we looked at our line was, let me do this. We had y hat, okay, equals 248.6 plus 2.60. This is from the previous page, times x, okay, where x equals the tapping. Okay, so that was just the equation from the previous page. Okay, so what we're going to do is we're going to take this 4 seconds, plug it in here, and let's find out what our predicted value is for tapping for 4 seconds. So I can go in here and say my predicted value, so y hat equals 248.6 plus 2.63 times 4. And so your y hat is equal to 259.12. So based on our line, okay, we expect, we predict that when you tap the can for 4 seconds, you're going to get 259.12 milliliters of soda remaining. All right. So now to find the residual, so now to calculate the residual, you take the observed value, observed y, minus the predicted y. In this case, our observed y was 265. That's what we actually got when we did the experiment. Minus what we predicted, 259.12, and that's going to give you a residual of 5.88. Okay, and I want you to think about what does this residual mean? Did our line underpredict or overpredict? If you have a positive residual, does that mean your line underpredicted or overpredicted? Okay, think about that. Last big thing I'm going to talk about in this video is what is the least squares regression line. Okay, so that's what we're going to call it from now on. It's the least squares regression line. Or what's the best regression line? It's the least squares. So, and I'm going to show you something that's kind of cool in class revolving the least squares about the line of best fit. So the best fit line is called the least squares regression line. Okay, and what this does, okay, and I'm going to actually see if I can do this. I'm going to box in the word least squares, because that's the most important part of this. Okay, so least squares. And the reason why it's called the least squares regression line is because the LSRL, which is the acronym for it, least squares regression line, okay, takes the sum of the squared residuals. So it takes all the residuals, squares them all up, right? And tries to minimize that value. Okay, so it's trying to make the squared residual as small as possible. And the easiest way to see this is with a little picture. So if I draw, okay, so we have little axes like so. Okay, a little XY axis, and I'm just going to do a small little data set. So dot here, dot here, dot here, dot here. Okay. Okay, something like this. Okay, your line of best fit. Okay, this is just an approximation. Is going to go something like this. Okay, and so what is your? So when you run this on your calculator, which we're going to go through. But I kind of want you to show, have you guys see the interpretation or like where this is coming from. So each one of these, so these are your actual values, okay? This line represents your predicted values. So your residual is going to be the distance from each one of these dots down to the line, okay? So each one of these things is a residual, okay? So all these little vertical lines, okay? Something like this. And so what your calculator is doing is it's taking those and turning them into squares. So now I can take all these and turn them into squares, like so. So it's taking all these areas and making the areas as small as possible, okay? That's going to be the line that best fits this data set. So that's kind of what's going on when you type this into your calculator. I'll show you how to do that. Right? So when you type all these things into your calculator, you get something like this. Okay, we have some squares above the line, some squares below the line. So if you sum all these up, you take the square, you square all the residuals, sum them all up. The smallest value you can make is going to be your least squares regression line. So for example, if I were to change my line and make the line go something like this, which obviously isn't going to be the best one, but let's say I predict that that's going to be my line of best fit. Then when I go back in and I draw these regression or these residuals, do this in blue. Okay, so you have like all these values where you have massive residual here. Okay, so you have all these dots coming from. Okay, so you have something like this. If I square all these, I'm going to have massive residuals, residual squares. Okay, and as a result, this green line isn't going to be a line of best fit. Okay. So the line of best fit is the one that makes up all these little squares as small as possible. That's kind of the idea behind all this. Definitely something interesting. We'll talk about this a little bit more in class. But that's going to be it for this video. We'll kind of do a little activity where we look at M&Ms and hand size, and we'll do some of that. And then we will also talk about how to get the least square regression lines on your calculator and correlation and R-squared values. But that's it for this video, guys. If you have any questions, please let me know, and have a great rest of your day.